of things we're going to look at are polymers. And polymers, or the ones we're looking at, addition polymers, are formed when you have unsaturated hydrocarbons being reacted. So what are the two functional groups that we've learned about that are called unsaturated hydrocarbons? Alkenes and alkynes. Cool. So double bond or a triple bond. So the first thing I want to go through in our skills is some definitions. So well, you might have met some of these before in junior science or year 11, but we may not have as well, and that's okay. So mer means unit. So polymer means many units. So what we've got is things where you can see something being put together lots and lots and lots of times. I'm talking about millions of times and more. So it's not just one or two, it's millions of them. So a polymer is a chemical compound made up of many repeating units. So units that we keep seeing over and over again. So a good example would be polyvinyl chloride, PVC, which is used for clothing, for plastic pipes, that sort of thing. Polyvinyl chloride, if I looked at a section of polyvinyl chloride, it looks like this. Whoops. And keeps going on and on like this. And can we see a wee pattern in that? Okay, you can see that it goes CH2, CHCl, CH2, CHCl. So that CH2, CHCl must be our unit. And I've only shown a little tiny minuscule piece of this polymer, but because it's repeating itself over and over again, I've got a unit that is repeating itself over and over again, then I can be pretty confident that this is a polymer, many units. The monomer that we can pull out of it is found by finding that repeating unit. So we said that this thing here, CH2, CHCl, keeps being repeated. That's what we call a repeating unit. So we could actually draw that out, and that would be our monomer, the thing that it's made from. So mono, one, mer, unit, one unit from the polymer. If I write CH2, CHCl like this, then I have to go to my other organic chemistry knowledge and go, what does that really actually look like? And this is the hint that we go back to, that these are addition polymers, which involve an unsaturated hydrocarbon. Here, all of these carbons are saturated. So that makes a liar out of me, doesn't it? Well, not quite. The monomers are unsaturated. The polymer often is not. Okay? So if I was to draw this one out, you can see that the carbons don't have enough chemical bonds when I draw the monomer. So that's where we go back to our definition of these being addition polymers, that they start with an unsaturated hydrocarbon. So I put another line in there, and I check again. Does this now give every carbon 4 bonds? And it does. If the answer is no, you put another line in there and make it a triple bond. Okay, so if the carbons when you pull the monomer out will not have enough bonds. So you make an extra line in there. If that still doesn't work, you add another one in there to create a triple bond. Alright, so there's a couple of confused looks. When I didn't have that one in there, and I just drew that out from the repeating unit, each carbon only has 3. It's not enough. But because these are addition polymers, they started with a monomer that is unsaturated, double or triple bond. So I make it a double bond to see if that gives every carbon 4 chemical bonds. And it does in this example, so that's cool. If I had, for example, I will wipe this one off, sorry. Let's just put hydrogens there because it'll make it easier. If I had this as my, as what I've got, I should have made a mistake there, sorry. Oh no, I haven't. Then when I break it out, here's my repeating unit, okay, and it's already got a double bond in there. So if I'd have to add another one, and it's already got a double bond, so surely that should be enough. But it's not. It's only 1, 2, 3. So I need a triple bond in there to create the monomer. So the monomer there would be ethine. Right? I don't think that actually exists, but it's one I just came up off the top of my head. So just be aware, you're adding an extra bond in once you've identified the monomer. Okay, you're just having to add one more bond. I'm going to get rid of that because it may confuse. Right, so at the moment, let's tick off what we've done. We can define polymer, we can define monomer. Okay, we have actually been able to identify the repeating unit. That's this thing here. I put a little n next to it when I'm identifying it because n means millions of them. Okay, it means a huge number. All right, so that is my repeating unit. I've found something that keeps repeating itself. So I can tick off that one. From it, I was able to identify what the monomer was. So I can tick this one off, and I'd be expected to name it. So what would the name of this be?
1-chloroethene.
Good, and you don't need the one in this because either carbon could be the one carbon, okay, but it's chloroethene. When it was first used to make polymers, they called it vinyl chloride. So a good question could be, they gave you the structure, they asked you to identify the repeating unit. From this, draw out the vinyl chloride monomer, and then give the IUPAC or systematic name for vinyl chloride. So you'd say, oh, vinyl chloride is chloroethene. And that would be a question. You also would be asked how this was polymerized, so how it was turned into this polymer. Okay, I'm going to take a different example. Okay, I'm going to take a different example to go through that process. Okay, so what if you were told that this well, I've made a mistake. I haven't got it right, so I'm just missing hydrogen. What if you were told that this was the monomer, and you were asked to draw a section of the polymer that it forms? It looks pretty daunting, doesn't it? Especially the way that it's been drawn out. It looks really daunting. So here's what you're going to do. You're going to look at the double bond. Look for a double or triple bond. Carbon-carbon double or triple bond. And there is one in this compound, isn't there? So what you do is you draw it out around that. And see how I've got things going up and down here, not on the angles? That helps me with making this. So, I'm going to draw it like this. So I'm going to take that hydrogen, put it there, that one there, that CH2COOH will go up the top, and that one down the bottom. Then I'm going to put it next to two more of them. I'm going to draw it again twice, because you'll notice that I put 3 repeating units here. Usually in NCA they ask you to show 3 repeating units to show that you understand what's happening. Okay, you'll notice I've gone up and down with these. So I'm going to draw the same thing next to it. And I've run out of space, so I'll just draw that a little bit differently. Okay, so now I've got 3 of the monomers next to each other. For polymerization to occur, this sort of polymerization, you normally need a catalyst that we call a polymerizing agent. It's just the name we have to use for polymerization, but it is effectively a catalyst. And you need quite a lot of heat. So you need a lot of the monomer, a large amount of the monomer. You need a polymerizing agent, and you need heat. What those two things do is they allow for the double bond to break. And one electron from that goes onto that carbon and one goes onto that carbon. That causes the breaking of a neighbouring one and the same thing happens. And so you start getting a chain reaction. And so if there's an electron going in from that one, an electron going in from that one, 2 electrons in between 2 atoms creates what?
A bond.
A bond, a chemical bond. So because they're both being shared, we get a covalent bond in that space there. Is it starting to look a little bit like a much more complicated version of our PVC at the top? Okay. Same thing here. One of those electrons has gone here, which has caused that that bond to break. Neighbouring one breaks, and the same thing happens. And then it'll carry on each way.
What happens at the start and the end of it?
I love that question. At the start and the end. Okay, so always one that's a bit of a tricky one. My understanding is at the very ends is that often these things are done in an aqueous area, so you probably have an H or an OH just on there. It's one of those questions I haven't really explored enough. I just always look at the middle of polymers.
Yeah.
It's easy when you get natural polymers like proteins, for example, because they have a terminal end that's an NH2 or a COOH.
Mm-hmm.
Yeah, these addition polymers are a bit harder because there's no other chemicals to add something onto the end to make it all good. But it must be because they're stable. They're plastics. These are our plastics and our things like that. So my inference, and it's only an inference, is that there's an OH on one end and there's an H on the other from water being present. Okay. So sorry I don't know the exact answer for that. By the way, I think I've got this right. Pretty sure the common name for this is vinyl acetate. And so this is a section of a glue or stuff you can use to make some slime called polyvinyl acetate, PVA. Alright, so so that's the link. So now we've looked at being given a polymer, drawing it a more sensible way to create a section of our monomer. Again, we should identify our repeating unit. So I'm going to take the 2 middle ones because it's easier. And put a little N next to it to show that there's lots and lots and lots and lots and lots of them. Okay. So now I can show a section of the polymer given its monomer. And all you need to know for explaining the process is the 3 things you need. The monomer needs to be what in nature? So what does it need to be? What type of compound? Unsaturated hydrocarbon. Okay, that's what that is and that is. Unsaturated because they have double bonds. And there's 2 more things we need, and I have written them up.
Heat and a polymerizing
Heat.
agent.
Cool. And a polymerizing agent is effectively a what that you've met before?
Catalyst.
Effectively a catalyst. Okay, that is all you need to know about polymers. The trick now is to practice questions on it. So after this, and I'll photograph this for you as well in case you don't get finished in class, I'm going to give you some examples of some polymers and I'll try and get you to identify the monomer from it. I'm going to give you some monomers and I'll ask you to draw a section of the polymers for them. They will have parts in their structures. You go, what the heck is that? It's irrelevant. I could draw an elephant if I was good at them, and you'd draw the elephant there. Of course I'm not going to. But my point is, if you see a function, you go, oh, we've never met that before. Don't freak out. Just draw it how it is, because clearly that's not the bit that's being polymerized. It's the side chain of the polymer, which is what this is. It's what the chlorine is a side chain. The CH2COOH is a side chain. So it'll be the side chain. If you go, I've never seen that functional group before, just copy it the way that it's been given to you. Any questions before I turn that off? Cool.